This presentation covers the Department of the Navy SBIR STTR transition program for the Meld Phase 2 SBIR contract titled Meld 3D Print Large Metal Forgings. The Phase 2 contract number is N68335 TAC 21 TAC C0188. The topic number is NASAH5.02 NAVC. The award-winning patented Meld technology achieves forged equivalent properties through the solid-state printing process. This enables a new form of manufacturing which can greatly reduce the material utilized and lead time necessary to receive the end part. The Meld technology has been around for 15 years, but the company was stood up in 2018. Since the company's inception, there has been numerous awards and recognition within the defense, technology, and additive community, which we are grateful for. Our company's purpose is to disrupt manufacturing and repair metals to serve humanity with the power of 3D printing, on Earth and in space. We will accelerate technology adoption by delivering reliable machinery capable of printing at unsurpassed speed at any size and any metal with forged properties. The purpose of this SBIR Phase 2 was to cover several initial topics of interest the Navy has for utilizing the Meld technology. This contract satisfies the following deliverables. A Meld Model L3 machine, shown in the image on the right, to be placed at a location of NAVC's choosing. Ti 6-4 qualification data. Aluminum 5083 qualification data. A demonstration of a printed titanium ball valve, which would be a representative replacement of a current forging or casting. This would be an example of a new construction scenario where the ball valve is a long lead time part with traditional manufacturing. Instructions for the Navy on how to replicate the printing of the demonstration ball valve. A repaired aluminum weld joint crack, which is an example of using the Meld process for a repair scenario in which traditional manufacturing currently experiences challenges. Instructions for the Navy on how to replicate the printing of the repair. And finally, training on the Meld machine and transition to the Navy. The Meld process is a solid-state process, meaning that the deposited material never reaches melting temperature at any point in the printing process. This is the biggest difference between the Meld process and every other additive manufacturing technology. Because the metal is never melted, no toxic chemicals are burned off, which allows the process to operate in open air instead of a vacuum. There's also no limitation on the size of the parts that can be produced. For example, the U.S. Army awarded the contract for the world's largest metal 3D printer to be built using the Meld technology. The build volume is 12 feet high by 20 feet wide by 30 feet long for producing jointless holes for the underside of their tanks. If customers want to go larger, they can. Since the metal is not reaching melting temperature, the material is fully dense, defect-free, and achieves forged equivalent properties. This slide shows the forged equivalent mechanical properties that have been achieved across various metals. There has not been a metal that the Meld process hasn't been able to deposit as of yet. The Meld technology is currently available in commercial off-the-shelf machines and custom machines for our customers to purchase. Training and printed parts as a service are also available for our customers to purchase. We currently have active DoD, DOE, and NASA programs focused on printing various materials and parts to advance the individual technology readiness level, or TRL, of specific metals. The image shown here is a perfect example of being able to incorporate purchased plate with wrought properties and deposit material locally to rapidly achieve a near-net shape of the part. The excess material will then be machined off from both the substrate and the deposited material to achieve a smooth surface finish and the necessary tolerances of the final part geometry. Due to the solid-state nature of the Meld printing process, Meld can perform in ways that other metal additive manufacturing technologies cannot. On average, Meld deposits 20 to 30 pounds per hour in aluminum. Meld has no issues with porosity and achieves fully dense parts with forged equivalent properties. The Meld process is predictable and achieves repeatable results. Users of the Meld technology can source their feedstock from any of their traditional metal vendors or suppliers. There are no limitations to the size of the parts that can be achieved, and existing parts can be repaired with the Meld process. At Meld, we have 3 streams of revenue that make up our business model. The first is manufacturing machines for sale to our customers in the defense industry, commercial industry, and universities and research labs to use in their fields as they see fit. The second stream is material qualification and parameterization. At Meld, we will take on project efforts and programs to advance the TRL of materials that have lower sets of data around them or are lower TRL on the individual metal. The third stream is part manufacturing. We will print parts for customers in materials that we have already parameterized and that have a high enough TRL. Materials that fall into this category are aluminum 6061, aluminum 7075, and titanium 64. Meld Manufacturing Corporation are the inventors of the Meld process, also known as additive friction stir deposition, or AFSD. We are a woman-owned small business and located in Christiansburg, Virginia, near Virginia Tech. My name is Wes Downs, and I'm a senior application engineer for Meld Manufacturing, and our sole owner and CEO is Nancy Hardwick. If there are any follow-on questions, please feel free to reach out to me, and I will do my best to answer them. Thank you for your time today.